Welcome to Oryx Learning. Today's lesson is going to be on Unit 4, Systems of Equations, Lesson 1, Solutions of Systems of Equations. Here we have Superman getting ready to fight an alien. When will Superman collide with the alien, and how high above the city will they be? The best way to solve this problem would be to put a grid over the entire city and see where they intersect. So in this case, we'll label the horizontal axis with seconds, and we'll go up by 1 second, so an interval of 1. And the vertical axis, to figure out how high they are above the city, we'll label in meters, and we'll go up by 10 meters for each interval. Here we can see if we follow where they intersect, they seem to intersect at the point 8, 100. If I follow the flight path of Superman, I can see that he has a y-intercept of 20 and a slope of 10 over 1, up 10 over 1. If I follow the flight path of the alien, we can see that if we extend it past where they collide, he would have a y-intercept of 140, and his slope, being it goes down, would be negative 10 over 2, or negative 5. So the alien would have an equation of y equals negative 5x plus 140, and Superman would have an equation of y equals 10x plus 20. Now let's take those equations and make sure that the solution satisfies both of the equations. So back to our original equations here, we have y equals 10x plus 20 and y equals negative 5x plus 140. They appeared to intersect at the point 8, 100, so let's check our work. If I substitute in an 8 for the x in both equations and 100 for the y in both equations, that should satisfy both equations. So here we have on the left 100 equals 10 times 8 plus 20, and on the right 100 equals negative 5 times 8 plus 140. In both cases, they will simplify down to 100 equals 100, satisfying both of the equations. That means that Superman and the alien will indeed collide at the point 8, 100, meaning that they'll collide in 8 seconds at 100 meters above the city. The equations for Superman and the alien came together to make a system of linear equations. A system is two or more objects that come together to make a group. For example, a bus system, a school system, or a governmental system. Systems of linear equations are a collection of linear equations involving the same set of variables. You'll notice in all three examples shown, they all have an x and a y. Now the variables don't always have to be x and y, but whatever two variables you use, they must show up in both equations. A solution to a system of equations is the value of the variables that make all the equations true. There are three options for a solution to a system, the first being one solution. If the two lines intersect at exactly one point, that point is the solution and there is one solution. If you have two lines that do not intersect, or parallel lines will always have no solution. And our third option, if we have something called coinciding lines, or a line directly on top of another line, so you can see here we have the green line, a black line placed directly over top. They intersect at infinitely many places, so this solution is called many solutions. How many solutions does this linear system have? So we can see from the diagram that the lines in this system are parallel. If the lines are parallel, they do not have any points of intersection, and we can say that the lines have no solution. If y equals negative 2x plus 5, find y when x equals negative 3. So here we need to substitute the negative 3 in for the x value in the equation. Negative 2 times negative 3. A negative times a negative will become positive. So y equals 6 plus 5. Simplifying further, we'll get 6 plus 5 is 11. So when x equals negative 3, y will equal 11. Determine if the coordinate point negative 3, negative 5 is a solution to the linear system. Y equals 2x plus 1 and y equals x minus 2. In order to be a solution, the point will have to satisfy both equations. So I can substitute in a negative 3 for both of the x values and a negative 5 for both of the y values to see if they hold true. In the first equation, we'll have negative 5 equals 2 times negative 3 plus 1. Simplifying, we have negative 5 equals negative 6 plus 1, or negative 5 equals negative 5. So it does satisfy the first equation. Looking at the second equation, substituting in our values, we get negative 5 equals negative 3 minus 2. Negative 3 minus 2 is negative 5, so negative 5 equals negative 5. This point also satisfies the second equation. Therefore, it is a solution to the given system. Determine if the coordinate point 0, 2 is a solution to the linear system. 3x plus y equals 2, y equals x minus 2. So again, we'll substitute the x value of 0 in for both the equations and the value of 2 in for the y in both equations. For the first equation, I will get 3 times 0 plus 2 equals 2, or 2 equals 2, so it does satisfy the first equation. In the second equation, I'll get 2 equals 0 minus 2, or 2 equals negative 2. We know that 2 does not equal negative 2, so it does not satisfy the second equation. If the coordinate point does not satisfy both equations, then it is not a solution to the given system. In our next example, we have Miriam and Khalid, and they are training for a school race. Miriam runs 1.5 kilometers the first day and adds 0.2 kilometers to her distance every day. Khalid runs 0.7 kilometers the first day and adds 0.4 kilometers to his distance every day. Their distances can be modeled by the system below, where y is the distance in kilometers and x is time in days. After 5 days, will they both have run exactly 2.3 kilometers? So for this one, we have to set up our system of equations, which for Miriam is y equals 0.2x, the amount that she adds per day, plus 1.5. 1.5 kilometers is how much she runs the first day. For Khalid, we have 0.4x, how much he adds per day, plus 0.7, the amount that Khalid runs the first day. So if the first day is already taken into account, we only have 4 more days to add up for the total 5. So we're not going to substitute in a 5, but rather a 4. So now we have 2.3, the total y value, equals 0.2 times 4 plus 1.5. That simplifies to 2.3 equals 2.3. In Khalid's equation, if we put 2.3 in for y, and again 4 in for x, because the first day is accounted with a y-intercept, our b value, then we get 2.3 equals 0.4 times 4 plus 0.7. This also simplifies to 2.3 equals 2.3. So the values satisfy both equations, so we can conclude that both Miriam and Khalid will run 2.3 kilometers after 5 days. So in review, systems of linear equations are a collection of linear equations involving the same set of variables. A solution to a system of equations is the value of the variables that make all the equations true. And remember, there are 3 options. If the lines intersect, they intersect at one point, so there is one solution. If the lines do not intersect, they are parallel lines, and they have no solution. And if the lines are the exact same line, they're coinciding lines, one on top of the other, they have infinitely many places of intersection, so therefore they're called infinite solutions or many solutions. That is the lesson for today. Thank you for joining us.